Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all work, energy and power. This is the 18th lesson of your grade 10 science textbook. And as you all can see, it is a physics lesson. So here we are going to look at how we can get work done by applying a force. And also when work is done, how energy is used there, or what type of energy is involved with movement of objects, or when work is done, what type of energy is involved with that, and also the power. When we say power, how the work is done within a certain time period. Based on that, we can calculate the power of different instruments, or we can consider the power as it is. So those are the concepts we will be discussing. With that introduction, I'll move on to the contents of this lesson. So work, energy and power. When we say work, now let's say if I tell you to bring something to me, bring your book towards me. So you have to carry the book, you have to lift it from the table and you have to walk towards me, you have to give it to me. To do all these, you need to apply a force. So when you apply a force, you are moving an object. So when you do that, you are doing work. The same way, let's say you have a chunk of clay. If you apply force, if you make it into different shapes, to do that you might have to press the clay, you have to lay it out into a thin layer, or you might have to roll it, you have to make it into shapes. So to do that also, you need to apply force. So there you change the shape of the object by applying force. Either you move the object or you change the shape of the object. Then we consider as work is being done. To do this work, we need energy. Now the ability to do work is energy. Now sometimes we say, no, you all are tired, you can't do work, you don't feel like doing work, or you're not active enough. Why is that? The energy is less. Same goes for objects. When the objects have more energy, they can do more work. So like that, work is related to energy. So energy is the ability to do work. And as I said before, power. Now if one person can do more work in a unit time, whereas another person does less work in the same time period, then we say they do work with different powers. The same goes for instruments as well. So the amount of work done in a unit time is considered as the power. So that is the introduction to work, energy and power. We will be discussing them in a little bit more detail, and also we'll be doing some calculations related to that. So with that, students, I'll move on to the next slide. Work. You have learnt before that an object is said to have done work if its position or shape change under the action of a force applied on it. Let us investigate further about work. So although I gave you all some examples, I will go into a little bit more detail here. Now let's say we have an object. Now to this object you apply a force. Let's say we apply a force of, let's say, we'll say 2 Newton. So when you apply that force, this object will be pushed towards a certain direction, the direction in which you apply the force. So after some time, what will happen? This object will change its position. Maybe the object will come to this point. So from here, the object has moved to this point. So there is a distance moved by the object. So we apply a force of 2 Newton. By applying a force, we make the object to move by a certain distance. So then we say work is done. So you apply the force and make an object to move, then there is work done. That is one instance. So as examples, I told you all, if you are carrying your book, if you are carrying your school bag, if you are carrying your laptop, anything, any object, maybe you are carrying a bag of rice. So all those are work done. Why? You are applying a force and you are moving the object. You can carry it, you can push it, you can pull it. All those come under work. The same way, like I told you all before, let's say if you have a chunk of clay, you put force. From the top, you press the clay down and you spread it out like that. So there, from this shape, you get a different shape. So to do this also, you apply force. So there also, there is work done. So this is one instance where work is done. This is the second instance where work is done. So you can see that an object is said to have done work if its position, that is one, or shape, that is the second one, change under the action of a force applied on it. So this is the first example, that is the second example. Is that clear, student? So from this, we will try to understand a little bit more. Now let's say this is one box. I said we need to apply 2 Newton force. Say if you have 2 such boxes, what will happen there? You will have to apply more force so that you can move the 2 boxes from here to there. Then you need to apply more force. So then there will be more work done. Say if you are to move 4 boxes, you will have to increase the force further. So work will depend on the force you apply, or depending on the object that you need to move, you might have to apply different quantities of force and or different magnitudes of force, and based on that there will be different amount of work done. The same way, now if we consider the box going from here to here, for that the distance moved by the object when you apply the force is a certain value. But if you have to move it further, then you have to keep on pushing the object further. So there also you might have to do more work. Let's say if you are to walk from home to school, carrying a bag of 3 kilograms. And if the distance is about 500 meters, you will need to do a certain amount of work. But if the distance is more, if you have to walk 1 kilometer, with the same bag, you will be doing more work. The same way, if you are carrying a heavier bag, then also you will be doing more work. So from this, you all have an understanding that work depends on the amount of force applied, that is the magnitude of force applied, and also the distance moved by the object when the force is applied. We will try to understand that with more examples. First one, before looking at the diagram, we'll read what is given. If we place an object on a horizontal plane, you all know why we always say a horizontal plane. This is a horizontal plane and normally it has to be a smooth surface so that there is no friction. And also when we say horizontal plane, it's easier to apply the force in a certain direction and the object will move only due to that horizontal force. If the plane was inclined, then there can be other effects as well. Even the effect of gravity can change the movement of the object. So to avoid that, we always say horizontal plane. If we place an object on a horizontal plane as shown in figure and apply a constant force of 1 Newton on it, until it moves a distance of 1 meter along the direction of the force, the work done by the force is defined to be 1 joule. And it is written as 1 joule capital J. That is the standard unit of work done, or standard unit of work, joules. This is named after the scientist Prescott Joule. So here, if we look at this example, so you can see the horizontal table here, the object is there and there is a force of 1 Newton applied onto the object. By applying that force, the object is moving in the direction of the force. So this is the direction of the force. So initially the box is here and now finally the box is here. And it has moved a distance of 1 meter. So everything is indicated in the diagram as well. So from this, if we calculate the work done, like given to you, 1 Newton of force. So I told you all work done is being calculated as 1 Newton force into it moves by a distance of 1 meter in the direction of the force. So that is 1 meter. If you multiply that, you get the value as 1 Newton meter. But this Newton meter is defined as joules. Work done is joules. So that is equal to 1 joule of work done. Can you all understand that? So we apply the force and the object moves. Force multiplied by the distance moved by the object gives you the work done. So like I said, if we increase the force, work done will increase. If we increase the distance, then also the work done will increase. So from that, you all can understand that work depends on both the force as well as the distance moved by the object. To understand that further, we will move on to another example. Before that, if you read this, you can see moving an object by 1 meter under the action of a force of 1 Newton. Then the work done is 1 Newton multiplied by 1 meter. So the work done is equal to 1 joule. That is what is given here. So that is how we define work. Is that clear, student? So then we'll move on to the next slide. If a constant force of 2 Newton. So here you can see the magnitude of force is changing. So like I said before, work depends on magnitude of the force as well as the distance moved by the object. Here we are changing the magnitude of force. 2 Newton acts on the object until it moves by 1 meter. The same distance, but the magnitude is different in the direction of the force. Then the work done on the object is 2 joules. Now can you all see the relationship? When we increase the force, then the work done increases. So from that also you all can understand the relationship. So first we'll look at the diagram. Here again you can see the horizontal plane, the same object. It moves by a distance of 1 meter. So initially here, finally the object is there. But the force has increased. We have increased the magnitude of force. So then the work done increases. When force is 2 newtons, distance is 1 meter, work becomes 2 joules. So here also you all can understand the relationship. Magnitude of force multiplied by distance will give you the work. Moving an object by 1 meter under the action of a force of 2 Newton, then the work will be 2 joules. So when you increase the magnitude of force, work increases. So from these students, we can come to this understanding. Magnitude of applied force increase, then the work done increases. So from that you all can understand that the work depends on the magnitude of force. I'm sure you all can understand that clearly. So with that, we'll move on to the next example. Again the same thing, but you all can see similarly, if a constant force of 3 Newton, again we are increasing the magnitude of force, acts on the object until it moves by 1 meter in the direction of the force as shown in figure. Then the work done on the object is 3 joules. So again the same relationship. We increase the magnitude of force, the work done increases. So here again you can see the same diagram, horizontal surface, a table with a horizontal surface. We have the object there. We apply a force of 3 Newton. So object moves from here to here and the distance moved is 1 meter. But the work done becomes 3 joules. Why? We have increased the applied force. So when this increased, the work done increased. Moving an object by 1 meter under the action of a force of 3 Newton. So again from this, if we try to understand the relationship, work equals force into distance moved. Now you all can easily understand this relationship. So force is 3 Newton and distance moved is still 1 meter. We get the value as 3 Newton meters. But as I told you all, this Newton meter is equal to joules. So that will be equal to 3 joules. We increase the magnitude of force, the work done increases. So that is the relationship. You apply more force, more work will be done. So that is what we can understand from the 3 examples that we discussed so far. So then I'll move on to the next slide. Therefore, work can be given by. So the equation I told you all. What is it? We saw that the relationship between work, magnitude of force and the distance moved by the object. When you multiply magnitude of force by the distance moved by the object, you get the work done. So that is the definition as well as the equation for work. Okay, so if we write the equation here, work done by the force is equal to magnitude of force into distance moved by the object in the direction of the force. So work done by the force is equal to magnitude of force into distance moved by the object in the direction of the force. So for this, of course, we have looked at different examples. So let's say we have an object and it moves to this distance after applying the force. And let's say the distance moved is 2 meters and the force that we apply is 3 Newton. Earlier we saw how the work increased when we increased the magnitude of force. But we did not look at an example where we changed the distance moved by the object. So here, earlier you all can remember students, when we apply 3 Newton force, the object moves by a distance of 1 meter and the work done was 3 joules. But here, the force applied is 3 Newton, the same value, same magnitude, but the distance moved by the object is 2 meters. So, how do we calculate work done? Work done. Now, here you can see work done by the force. Force applied is what? 3 Newton. So, that is the magnitude of force. Magnitude of force into distance moved by the object. So there. What is the magnitude of force? That is 3 Newton. And when we apply 3 Newton force, the object moves by a distance of 2 meters, and that is always in the direction of the force. That you have to remember. So, in other words, we can also call it as the displacement caused by the force. Because you all know, students, displacement has a direction. So, if the distance moved is in the direction of the force, we can call it as the displacement also. So, in our lesson, we will be using both the terms. Either you can say distance moved by the object in the direction of the force, or you can say displacement of the object. So, 3 newtons into 2 meters. So, here of course, it's going to be 6 Newton meters, but the standard unit is 6 joules. Joules is the standard unit of work. So, here we can say SI unit of work is joules. Earlier also we had this standard unit of work is joules, and joules is equal to Newton meter. If you take 1 joule, that will be equal to 1 Newton meter. Why? Because from that equation, you all know we need to have the magnitude of force applied multiplied by the distance moved by the object in the direction of the force. Is that clear, students? I'm sure you all can understand this equation and the calculation of work done on an object by applying a force and moving it from its position. So, with that understanding, we will move on to the next slide. There is an example given in your textbook, the worked example. Example 1. What is the work done if a force of 7.5 Newton acts on an object and displaces it by 8 meters in the direction of the force? So, here you all can see the term displaces. I told you all, since the object is being moved in the direction of the force, so the distance moved in the direction of the force, we can also use the term displacement, or we can say the object is being displaced. If we do the calculation, so what do we write here? Work, force into displacement, or you can write it as the full version, work done is equal to magnitude of force multiplied by the distance moved by the object in the direction of the force. Work done is equal to magnitude of force into distance moved by the object in the direction of the force. This is the complete equation. You all can write this, or you can just use this short form where you calculate the work that is equal to force into displacement of the object. So either way, you have to substitute the values. So work equals, force is given to you as 7.5 Newton into the displacement of the object is given as 8 meters. So when you multiply 7.5 into 8, you get the value as 60 Newton meters. That is equal to 60 joules. You don't even have to write this step again. Directly you can show the substitution and you can write the final answer with the unit joules. 7.5 into 8, 60. So the answer is 60 joules. Work done when you apply a force of 7.5 Newton and move the object by a distance of 8 meters. The work done is equal to 60 joules. That is how we calculate. Is that clear, student? I'm sure you all can understand this. So then we will move on to the next example. Example 2. The weight of an object is 40 Newton. So weight. So far we have been discussing force. But you all know force and weight. Weight is also a force. So if we say force applied or the weight of the object, it refers to the force. So the weight of an object is 40 Newton. What is the work done in lifting the object by a vertical distance of 2 meters? So here the movement is different. What is happening here? Now let's say the object is here. We lift the object to a certain height from here up to this point. So the object has a weight of 40 Newton, that is the weight, and we lift it by a vertical distance or height of 2 meters. So initially the object is here, but you lift it up. Now why do we use the term weight there? Because you all know, students, what is weight? An object has a mass and all the objects are affected by the gravitational acceleration. Gravity is pulling the objects down. So due to the gravity acting on a mass, there is weight. Mass into gravitational acceleration is weight. So here, when we lift the object, we raise it by a vertical distance. By lifting the object, we are doing work against the gravity. That is why it's always difficult. Now say you carry your school bag. If you are walking in a horizontal path, a linear path, it's somewhat easy. But let's say you have to go to the second floor or the third floor of a building. If your classroom is at a higher floor, then you have to carry that bag and you have to climb the stairs up. That is a little bit more difficult. Why is that? Because you are doing work against the gravitational acceleration. You are moving upwards. You have to lift the weight, you have to carry the weight, and you have to move up. You have to climb up. So there you are doing work. Same applies here. The object is here. It is raised or lifted by a vertical distance of 2 meters. Then also there is work done. What is that? Work equals force into displacement. Force into displacement. So what is the work done? They have given you the weight as 40 Newton. And the vertical height that is moved is 2 meters. So then 40 into 2, 80 Newton meters, that is equal to 80 joules. So again, like I said, students, you don't have to use this step always. You can skip this one. From here, you can directly calculate and write as 80 joules. Because you all know the standard unit to measure work is joules. Is that clear? So earlier we saw how objects are pushed along a horizontal plane. Here we saw an example where an object is lifted by a vertical height. So in both instances, there is work done. Why? By applying a force, we are changing the position of the object. Is that clear to you all? So then I'll move on to the next slide. Example 3. The mass of an object is 5 kg. Find the work done in lifting it upwards by 3 meters. So slightly they have modified. Now here you can see the mass is given to you, not the weight. So when they say mass of an object, now here you have an object. Initially it is below. So this object is being raised from this position to a height. This has a mass of 5 kilograms and it is being lifted upwards by 3 meters. Now, I told you all the relationship between mass and gravitational acceleration as well as weight. What is that related to? You all can remember, students, we have discussed the Newton's laws of motion. So, this is the second Newton's law of motion. From F equals ma, we get the equation W equals mg. I am sure you all can remember that. What is W? Weight is equal to what? Mass into gravitational acceleration. Gravitational acceleration. And what is work done? It is force into displacement. So force is weight. To calculate weight, we need to multiply mass by gravitational acceleration. So the mass of the object is 5 kilograms. We need to calculate the weight. So 5 kilogram into gravitational acceleration. What is the value? You all can remember, students, gravity. The exact value is 9.8 meters per second square. So, you all can remember, students, gravity 9.8 meters per second square. But for calculations, what do? We use a value, the rounded value, 10 meters per second square. You all can remember that. So, 5 into 10 meters per second square. So, 5 into 10, 50 kilogram meters per second square. That is equal to Newton. That is the unit of force or weight. So now that we know the weight, we know the magnitude of force applied to lift this object from this position to this position. So here we don't additionally give a force. We calculate the force using the mass and gravitational acceleration. Why? I told you all before. Here we are doing work against the gravitational acceleration. Gravity is pulling the object down. We are lifting it up. So, we do work against the gravitational acceleration. So, that is why weight, mass into gravitational acceleration becomes the force applied to do the work. So, if we calculate work done equals magnitude of force, into height lifted. So, we can say distance moved by the object, or we said the displacement of the object. You can also consider the height lifted. It's all the same. Since the object is moving this way, vertical height, we can write it as height lifted. So here, we calculated the force 50 Newton and the object moves by 3 meters. So that is going to be 150 Newton meter, that is equal to 150 joules. Is that clear, students? I am sure you all can understand this calculation clearly. So if we look at it again, the mass of an object is 5 kg. Find the work done in lifting it upwards by 3 meters. So since the mass is given, we need to calculate the weight of the object. So you know the equation, weight equals mass into gravitational acceleration, that is W equals mg. And g is gravity, gravitational acceleration, 9.8 meters per second squared. But for calculations, we use the value 10 meters per second squared. That is why 5 kg into 10 meters per second squared, you get the value for weight as 50 Newton. Then when we calculate the work done is equal to magnitude of force into, you can write it as displacement or height lifted. That is equal to 50 Newton into 3 meters. That is 150 Newton meters, 150 joules. So work done by applying a force of 50 Newton to lift the object by a vertical height of 3 meters is equal to 150 joules. So from all these calculations, students, I'm sure you all can understand that the work depends on both magnitude of force and also the displacement of the object in the direction of the force. When magnitude of force increases, the work done increases. When the distance moved by the object or the vertical height to which the object is lifted increases, the work done increases. So students, this is one way of doing the calculation. The same calculation, like given in your textbook, you can write in different steps. So for that, if I show you all the steps, this is another method. We can say, or we can write as mass of the object, mass of the object 5 kg. Then we have the gravitational acceleration, that is equal to 10 meters per second squared. Then you calculate the weight of the object. So that is going to be 5 kg into 10 meters per second squared. That will be equal to 50 Newton. The same calculation, but we write it using different words and the steps are slightly different. The order is different. There I calculated it together as one equation, but here we write it in different steps. So then, here what do? We lift the object. Like I told you all, we do work against the gravitational acceleration. So for that, what is the force we need to apply? That is the weight of the object, that is 50 Newton. So the next step, we can write it as the force needed to lift the object by a vertical height of 3 meters, that is equal to 50 Newton. So the same weight, that is the weight of the object, is the force needed to lift the object by a vertical height of 3 meters. Then the next step, height lifted is equal to 3 meters. Then we can say work done to lift the object that is equal to 50 Newton into 3 meters. Again 150 joules. So like I told you all students, the same calculation, but the way we write the sentences, it's slightly different. The steps and the sentences are different, but the same calculation. The same thing that I did before, I have done it in a different method. So you can either use this method where we directly calculate weight, then we write one equation for work done equals magnitude of force into height lifted and you do the calculation, or you can write it as different steps. Mass of the object is 5 kilograms, gravitational acceleration 10 meters per second squared, weight of the object 5 into 10, that is 50 Newton. Then you have the force needed to lift the object by a vertical height of 3 meters, that is 50 Newton, and the height lifted is 3 meters. Therefore, work done to lift the object is equal to 50 Newton into 3 meters, that is 150 joules. Both methods are the same. The way we write the sentences and the steps, it's slightly different. So whatever is easy for y'all can follow that method. Is that clear, student? So that now you have a good understanding as to how we need to calculate work. We will move on to the next slide. So here we have the exercise given in your textbook. Copy the table given below in your exercise book and fill in the blanks. So that is what you need to do. So look at the table. First column we have force. And you can see 20 Newton, then we have 15 Newton here, 0.75 Newton there. There is a blank space in between. Then the second column gives you displacement of force. So that is the distance moved by the object in the direction of the force. I told you all we can use the word displacement. So there are 2 meters, 80 centimeters, then there is a blank and 8 meters. Then in the third column, we have the work done. So you know the equation. Work done is equal to force into displacement of force. So work done, here it has to be calculated. Then 24 joules, 22.5 joules. Again, we need to calculate. So if you look at the full table, in each instance, you will have to calculate a different quantity. Either work done, force, displacement, or again work done. So for all these calculations, we use the same equation. What is the equation? Work done equals force into displacement of force. Displacement of force. If we do the first calculation. Now you all are supposed to copy this table in your writing book, then you need to fill it up. Here I will do the calculation here and then fill up the values there. So the first one, we have 20 Newton force, we have the displacement given, we need to calculate work done. So work done is equal to 20 Newton into 2 meters. So that's going to be 40 joules. So the first one, 40 joules. Is that okay? Yes. The second one then. Second one, we don't know the force and you can see displacement. It's given in centimeters, 80 centimeters. You all have to always look at the unit, students. From the beginning, we have defined when 1 Newton force is applied and the object is displaced by 1 meter, then only the work is in joules, 1 joule. So here the unit is 80 centimeters. Then you have to convert it to meters. So there, the work done is given to us. We need to find the force. So from this equation, work done equals force into displacement. We need to calculate force. So this is the equation. We know the work done, 24 joules. We don't know the force. I will write it as F. And displacement, although it is 80 centimeters, we need to divide it by 100 so that we get the unit as meters. 100 centimeters is 1 meter. So there, you will get the equation as F into 0.8 meters. Now if we rearrange, F is equal to 24 joules divided by 0.8 meters. So then you all can calculate the force applied. That is going to be 30, and here we find the force, so that is newtons. 24 joules divided by 0.8 meters, you get the value as 30 newtons. That is the value for the second one. This is 30 newtons. Then the third one, force is given to us, displacement is not given, but the work done is given. Again, if we do the calculation, 15 Newton and 22.5 joules. Third one, so work, force into displacement. We have the work done, 22.5 joules. We have the force, 15 Newton, but we don't have we have the force 15 Newton, but we don't know the displacement. So displacement will be we need to rearrange. So if you are to find displacement, we have to divide work done by the force applied. So 22.5 joules divided by 15 Newton. So here, now 22.5 joules is equal to 22.5 Newton meter. So 22.5 Newton meter, because you all know joules is equal to Newton meter. Then we have 15 Newton there. When you divide 22.5 Newton meters by 15 Newton, what is the value? You will be getting 1.5 meters. You can do the calculation. You will get the value as 1.5 meters. Is that clear? So here also from the units you can easily see Newton meters divided by Newton, you will get the unit as meters. So we are calculating displacement. Is that clear, students? So for the third one, this is displacement, that is going to be 1.5 meters. Then the last one. Force applied is 0.75 newtons. Displacement is 8 meters. Then the work done. That of course you can easily directly calculate. You multiply 0.75 by 8. So if we show the working, fourth one, work, force into displacement. Force into displacement. Force 0.75 Newton and the displacement 8 meters. So when you multiply 0.75 into 8, that is going to be 6 joules. 6 Newton meters, that will be equal to 6 joules. So if we fill the table, this is going to be 6 joules. So students, the question says copy the table. Copy the table given below in your exercise book and fill in the blanks. I have shown you all the workings. You only need to fill in the table. So you don't have to write the equation again and again. I have written it so that you will remember the equation easily. You all just need to do the calculation, substitute the values and fill in the table. So 20 Newton, 2 meters, work done is 40 joules. When the displacement is 80 centimeters and the work done is 24 joules, you have to remember you need to do a unit conversion. Displacement should be in meters. So then you get the force as 30 Newton. Thereafter the third one, force applied is 15 Newton, work done is 22.5 joules. When you calculate, you will get the displacement as 1.5 meters. Fourth one, force applied is 0.75 Newton, displacement is 8 meters, so the work done will be 6 joules. So I am sure students, now you all have a very good understanding as to how to calculate work done when you apply a force to an object and make the object to move. It can either move in the horizontal direction or it can be lifted by a vertical height. So either way, the work done is equal to the magnitude of force applied into the displacement of the object. So I will end this chapter and in the next chapter I will discuss energy with you all.